afternoon, ladies and gentlemen, or in this case, just gentlemen and people watching. Can you get out your notebooks or your reference books and write down median versus mean? Today we're going to look at when we use the median, when we use the mean, and why. Third.
Look, I was talking to him, but I didn't see the email.
Yeah, but no.
Been on that for a while.
There you go.
Auto rank out. Right, so that one.
Well, you all do, but the people watching it won't have.
The red button's the red button. We'll just sit here and talk to ourselves.
No.
You can talk to that and we'll
Doesn't matter. Alright, considering this small one, they'll just have to catch up. Small data set, imagine 8 women whose heights are here, and I've done stat calculation, so their X bar is 167, that's their mean, and their median, 167, 168. Their distribution looks like that. So it's symmetrical, and as you'd expect, the mean and median are basically the same, 167, 168. It does. Alright, imagine one of the women on the sofa has a child who's what, 50 centimetres long? How big are babies? About that? Yep, let's call it 50. What happens to the median? The median here has dropped by 0.5. So the median's barely changed. It's still 168. But the mean is down to 154. So the mean drops 10, but the median just drops 1 with that extreme value. Does that make sense? So especially in small data sets, the mean is subject to large movements. Now to make the mean more resilient, you can think of a large data set. So here, same group of women, I've just repeated it so there are now 122 of them. N is 122. If we change, and you'll notice that the median is 167 and the mean is 166. So mean and median very similar, and the distribution is basically normal. What happens, can anyone guess what will happen to the mean and median if I put a child in there again? Another 50 centimetre one.
Mean will go down.
Mean will go down, how much?
Median will stay about the same.
Mm-hmm.
Child, depends how high the child is.
Let's call it a 50.
Oh, wow, I was going to drop it there.
Well, let's see. That was the mean. It went from 66 to 65.
Big drop.
The,
Big drop.
the reason it doesn't go down as much is because there's 122 points of data. So if there are only 8 women in the room and you have a child, then the average height will disappear quite a large amount. But if there are 122 women in the room and then you add a child, the difference is only going to be small. It'll only drag the average down a small amount. Yeah, so there may be similar ones on the homework sheet. Alright, and you're right in that the median barely changes at all. The median is still 167. Alright, so the most important part of today is, well, being able to recognise mean and median from there. But, is this bit here? Yes, please get this down.
Copy and paste. Control P.
No, you're quite capable of copying down. On the left-hand side, we have median and IQR. And median and IQR is one way to measure the centre and the spread. Interquartile range is always associated with median. So this is like cutting it up into quarters and using box plots. And then on the right is mean and standard deviation. And standard deviation is how we measure spread about the mean. I will give you a couple minutes to copy and then I'll talk more about the formulas.
What is the, back on your mean calculator, which standard deviation do you follow?
Use SX. Yeah. Formulas? Yeah. Your calculator will always do it for you, but it is useful to know, especially the mean notation. And I'll explain what that weird E looking symbol is. No. Somerville, yeah. I'll scroll down to give you a sec with that. I'll just explain the two ways. So first thing, if we talk about median and interquartile range as a measure of centre and then spread, remember from box plot days, they look like this, pretty much. And that one there, line in the middle, median, and the interquartile range is the distance between there and there. The reason we don't use range a lot is because range is extremely affected by outliers, obviously, because all it will take is one different value to change a huge amount. However, median and interquartile range are pretty resistant is the word we use, and they don't change a lot. And that measures where the middle 50% of the data is. So we remember that 50% of the data belongs in here. And 50% is one side of the mean and another 50% the other. But you'll all know that from 11. Mean and standard deviation are not as resistant, and these are the two formulas that give it to us. This here is called sigma, or means sum of. Sum of all. Meaning x is each value, so x would be the height of each woman in our example. To find the mean, we would sum of all x, add them all together, and divide them by the number of data points. So this here is number. And the notation used in textbook is x bar for the mean. Now, standard deviation, you don't know how to use, but I think it's useful as far as trying to understand what standard deviation is to look at the equation. Essentially, what we do is for each data point, we subtract the mean away. So we basically say the difference between that data point and the mean. For example, if the mean is 160 and a particular woman is 165, we would do 165 minus 160 is 5. 5 squared is 25. And no matter what, even if that comes out as a negative number, it squares it to become positive. So that's like the distance away from the mean, squared and then essentially square rooted and divided by n take 1. The reason the take 1's in there is because we remove the mean from the data set. What this measures is basically the average distance from the mean each point is. The average distance from, well, the center point. And of course, we're used to seeing it in normal distribution like that. The terrible normal distribution. Alright, so when to use which one? First thing I should start by saying is if the data set is extremely small, 6, 7, 8 data points, they're both pretty much useless. The data sets that small aren't very effective in drawing conclusions about things. Like if you survey 7 people's favourite fast food, you're not going to get a serious survey about what the population of Australia's fast food choice. Bigger data size is always better. However, because median and interquartile range is resistant, we tend to use it if we would expect our data set to be skewed or have outliers. So we use this when it is skewed or has outliers, and we would expect that to come up. So examples of that would be house prices, for example, because in Hamilton there will be quite a lot of houses around 300,000, and then there will be several up around 700,000. But it would be skewed. You'd see quite a lot down the 200,000-300,000 mark, and then a couple up around 700,000-800,000. Couple usually in Churchill and by the lake.
I went to Cambridge for it.
Huh?
I went to Cambridge for it. So then, like average price in churches there is more better.
Which actually isn't that one. Alright. So, skewed or significant outliers, we use median. We use mean a lot of the time because it's more familiar to people. When people talk about average grade or average height, they tend to be talking about the mean. And we can do more with it mathematically. So I guess that 68, 95, 99.7 rule is just the start of what we can do mathematically with mean and standard deviation. So we tend to use the mean more often, especially if our data is symmetrical and outliers are not expected, or if there is a huge amount of data. Because as we saw before, when I brought up the list of women, there was 122 of them. Even with an outlier or two in the list of 122, the mean was still pretty resistant. So when there is huge amounts of data, or it's symmetric, use the mean. Otherwise, use median. Yeah, so. Alright. Yes, questions. So today, page 69, do those questions. And, let's move them up there so you can see them. Feel very free to use your CAS instead of calculating things manually.
I need questions to understand that.
Well, especially for question 2 and 3, because it's just a painful thing to do otherwise. I mean, why would you find mean or median by hand? Now you've got to calculate.
That'd be fun.
It's good you need to know how to find them by